Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at graphing inequality regions. We're going to graph things like y is greater than 3 minus x and x minus 2y is less than or equal to 4. Now, in order to graph these, we need to be able to graph straight lines. So I'll just quickly go through that. If you have an equation of a line in this form, y equals, y is the subject of the equation, then m, number in front of x, is the gradient, b is the y-intercept. To graph that line, you use the gradient intercept method. You mark the y-intercept, use the gradient to find a second point and join them up. If, however, the equation were in the form ax plus by equals c, so here y is not the subject of the equation, it's not obvious what the gradient is, so we need to use another method other than the gradient intercept method. We use the xy-intercept method. You let x equal 0 to find the y-intercept, y equals 0 to find the x-intercept, and then you join them up. Each of these methods involves finding 2 points that lie on the line and joining them up. So we need to know how to graph lines, because when we're graphing inequality regions, first thing you do is graph the line. You graph it as if it were an equation, not an inequality. So if the inequality is strict, if it's less than or greater than, not equal to, then you use a dotted line. And if it includes that, if it's not strict, if it's less than or equal to or greater than or equal to, you use a solid line. Then after that, you pick a test point to see which side of the line you shade, and then you shade the correct side of the line. All of that probably makes absolutely no sense, but I'm hoping it will after we do an example. So let's say we want to graph y is greater than 3 minus x. What we're actually going to do first is we're going to graph y equals 3 minus x. So because y is by itself, we're going to use the gradient intercept method. So the number, the constant term, is the intercept, the y-intercept. So first thing we're going to do is mark the y-intercept down here. Then we use the gradient to find a second point. The number in front of x, the coefficient of x, is -1. That means the gradient is -1. What that means is we go 1 to the right and 1 down. So we end up at 1, -4. That point there is also on the line. Now that we have 2 points that lie on this line, we join them up. But because this is a greater than, it's one of these, we're going to draw a dotted line, not a solid line. So I've drawn the line here, a dotted line that goes through the 2 points I found. So to graph the region here, we now need to pick a test point. That test point cannot lie on the line. So 0, 0 is a good test point. You can always pick it as long as it does not lie on the line. So 0, 0 is here. Clearly it doesn't lie on the line. What I'm going to do is substitute x for 0 and y for 0 into the inequality. So if I do that, I get 0 is greater than 3 minus 0 is 3. Of course, 0 is greater than 3 is absurd. That's not true. So 0, 0 does not satisfy the inequality. So that means that I'm going to shade the other side of the line, the side of the line in which 0, 0 is not. So what exactly have I found here? Well, of course, there are going to be infinitely many points, infinitely many pairs of x and y values that satisfy the inequality y is greater than 3 minus x. It turns out that all such points, all of the points that do satisfy this inequality are over here. They're on this side of the line. So basically, we've shaded in the region that contains all possible solutions to this inequality. It contains all of the points, the values for x and y, that would make this a true statement. All right, let's now try x minus 2y is less than or equal to 4. So our first step is we're going to graph the equation x minus 2y equals 4. So because it's in this form, I use xy-intercept method. I let y equals 0 to find the x-intercept. Well, if y equals 0, I've just got x equals 4. The x-intercept of this line is 4. Now, if x equals 0, I've got -2y equals 4, therefore y equals -2. I have found the x and y intercepts. Once you've got 2 points that lie on the line, you simply join them up. Because this is less than or equal to, I'm this time going to use a solid line to join them up. Okay, so once again, I need to decide which side of the line. Do I shade this side or this side? To do that, I pick a test point that doesn't lie on the line. Once again, 0, 0 does not lie on the line, so I'm going to pick it. I'm going to substitute x for 0, y for 0 into this inequality. So if I do that, I get 0 minus 0 is less than or equal to 4. That's actually true. This point 0, 0, this time, does satisfy the inequality. So I'm going to shade the side of the line that contains 0, 0. I'm going to shade all of these points here. So once again, we are shading all of the points, the values, the pairs of values x and y that satisfy this inequality. Any point in this region, for example, the point 0, 4, would satisfy this inequality here. There are infinitely many such points. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.